Hey Geometry, today we're going to be doing two proofs. I'm going to do an example proof with you, and then I'm going to do the exercise proof with you, and you're just going to be responsible for writing in the proof after you watch the video, or I would recommend writing the proof as you watch the video. So the example, proving lines. So we've been doing proofs. We've been doing two-column proofs, statements, and reasons. Prove lines are parallel. So our objective is to prove that two lines are parallel because of a transversal. So you can prove that lines are parallel by using postulates and theorems about pairs of angles. Examples: angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2. And angle 1 and angle 3 are congruent. So angle 1 and angle 3 are congruent. All right, so right off the bat, and then they want us to prove that AB, I'll put this in blue, they want us to show that AB is parallel to DC. Okay, so what we notice right off the bat is angle 1 and angle 2 are congruent, and angle 1 and angle 3 are congruent. So if angle 1 is in both of those congruent statements, now we can say that angle 3 is congruent to angle 2 because they're both congruent to angle 1. So they start off with a given. What was given? Angle 1 and angle 2 are congruent. Angle 1 and angle 3 are congruent. Given. Now, because notice angle 1 is in both of these cases, that means that angle 2 is congruent to angle 3. And that's called the transitive property of congruency. So now what we have is two alternate interior angles. So what I like to do is I like to extend these lines out. So I'm going to show you by extending these lines out. So I extended these two lines. And then here's our transversal here. So, whatever. So I extended those lines out, and so now what you can see is that angle 3 and angle 2 are alternate interior angles. And if alternate interior angles are congruent, then the lines are parallel. So what we've just proved that the two alternate interior angles are congruent. We showed that, so that means that AB is parallel to DC. So we proved what we were trying to prove. So we say, yay. So let's go ahead and do this. We're just going to do one proof. All right. Complete the proof. And I'm going to label what they give us. Angle 1 is congruent to angle 5. So angle 1 is congruent to angle 5. And right off the bat, we notice that those two angles, if I were to, and I'll show you what I'm saying. I'm going to draw a shape real quick. If I were to forget about that part right there and just look at where angle 1 and angle 2, we would say that those are corresponding angles from what we've learned. So angle 1 and angle 5, they're congruent, and they're corresponding angles. And as we learned yesterday, previously, if corresponding angles are congruent, then the lines that they go through that are cut by the transversal, they have to be parallel. That's the only way that can happen. So angle 1 and angle 5 are congruent. They're corresponding angles, so they have to be congruent, right? So that's one thing they give us. The next thing they give us is, I'll do this in blue, angle 15 is congruent to angle 5. So angle 15 and angle 5 are congruent. So now look at it this way. Turn this sideways. What am I doing? Okay, there we go. So now what that's saying is look at these two angles. So what we have are alternate exterior angles, And remember, if alternate exterior angles are congruent, then the lines that are cut by the transversal must be parallel. So, right off the bat, we have what we're dealing with. We just have to put it in words. So, the first thing they gave us was angle 15 is congruent to angle 5. So, we write given. How do we know that? Well, they told us that. So now they're going to tell us that angle 15 is congruent to angle 13. So angle 15 is congruent to angle 13. I'm going to do this in orange. Angle 15 is congruent to angle 13. And the reason they are congruent is because they are what we call vertical angles. So they are vertical angles. So we would say vertical angles are congruent. So that's our reason. Vertical angles are congruent. So now they're going to say angle 5 is congruent to angle 13. Well, that's because if angle 5 is congruent to 15 and angle 15 is also congruent to 13, angle 13, then angle 13 has to be congruent to angle 5. And so that is called the transitive property of congruency. Transitive property of congruency. All right. And because of that, we notice now that the two corresponding angles are congruent. And if corresponding angles are congruent, then the lines are parallel. So they're going to tell us that RS is congruent to, line R is congruent to line S. And the reason we can say that is because congruent angles, if corresponding angles are congruent, then lines are parallel. And if you notice, writing it is a little bit different than the way they have it. So, but if corresponding angles are congruent, then lines are parallel. So we proved one of the things. So we can put a little check mark that we proved R is congruent or parallel to S. Now we're trying to prove L is parallel to M. So the first thing we notice is that they're telling us the given. Well, one of these things we didn't put in. We already put that in. So now we're going to put angle 1 is congruent to angle 5. Angle 1 is congruent to angle 5, which means that it was given. And so automatically we realize that 1 and 5 are corresponding angles. So since they're corresponding angles, and we already know if corresponding angles are congruent, then the lines are parallel, we have just proven that L is parallel to M. And then we're done. We proved both things that they wanted us. We proved that R is parallel to S, and we proved that L is parallel to M. So you guys are going to go through and you guys are going to fill in these blanks that we did together. Any questions, reach out, guys. Have a good one. Bye.